Okay, everyone, let's get started. So, thank you very much for coming to this session. So, my name is Wang Sheng. I'm from the China Mobile. Today, my topic is next generation cloud network infrastructure. Let's go to the first. You may ask, so what is a computility network? So the computility network is a new type of information infrastructure that proposed by China, and which centers on the computing tasks, the network as its foundation, and use intelligence as its engine, and integrates multiple elements like data and like the security and in-depth, and provides integrated services. So the goal of the computility network is to promote the computing power to become a social level service, like the water and electricity. So now in China, the many use cases has already built or run on the computility network, like digital human, cloud gaming, LLM, and AI agents. And China Mobile has already built the world's largest and technically leading computility network infrastructure. So on the computing side, we have built 2 new super intelligent computing centers and 13 national and regional intelligent computing nodes, and with 2,600 plus Mac nodes, and covers mainly 300 cities in China. And also on the network side, that we have established the 400 gigabits high-speed direct connection network, and between the west and to the east China, and also we established the 520 milliseconds 3-level latency range. Means that we can connect the computing nodes and the users within the cities with a latency of 1 millisecond. And over the computing resource and the network resources, we also built the we call it the computility network brain. It's a platform for the orchestration and the scheduling our applications, and it has achieved the L4 level autonomous intelligence for the computing network operation and maintenance. And this is a brief architecture of the computility network. And on the bottom level is a computing network converged infrastructure. Consists of the core cloud and edge computing and terminal computing. And connections all these computing resources, we have the IP and the optical basic network. And based the computing network converted infrastructure, as we built intelligent brain, as I just said, it's a platform for the orchestration and scheduling and optimization of all the resources and the applications. And on top of this architecture is our services and operations. We will support like AI agents, embodied intelligence, this new application and services. So also in China Mobile, we have make extensive use of the open source softwares like the OpenStack and the Kubernetes, but also we contribute a lot our codes to the open source community. Like in OS, we have initiated the CFN working group, and I will briefly introduce the CFN working group. And also we started the Synerfuse project in area of AI and data, and the CFN ubiquitous scheduling project in Arduino, and also the Xdevelop in RFN. So let me give a brief introduce of the CFN working group. So we have established and launched the Computing Force Network working group in July 2022. And now our working group has 19 members, including the global telco operators, device vendors and cloud providers. And our working group is aiming to explore the typical use cases, working out the requirements on end-to-end workflow and architecture and key technologies. And this is the CFN working group organization structure, as we have one use case and architecture subgroup with 5 technical groups. And I will introduce these 5 technical groups. First is the ubiquitous computing scheduling subgroup. This subgroup is aimed to build an orchestration and scheduling platform which can perform the intelligent scheduling across the wide area, the cloud, edge, terminal, computing nodes, and with the multi-segment networks. So in this subgroup, they have the 3 key functions. The first is a real-time dynamic cognition. Is to perform the real-time acquisition and analysis of the status and the data of the underlying computing and network resources. And the second is an efficient integrated scheduling. So based on the real-time dynamic cognition and the status of the computing network resources. So to make the orchestrate and schedule the applications to most suitable nodes. And the third is a continuous optimization strategy to monitor the real-time application status and carry out the global migration and optimization based on the multiple factors like the cost, like the performance, and like to avoid some faults. And the second, the next subgroup is a computing native subgroup. So the goal of the computing native working group is to build a basic software stack that enables the cross-architecture development and the migration for the AI models and applications. And it has 4 key technologies like the unified programming model and converters, and the cross-architecture compilation optimization, and the computility abstraction, and the adaptive runtime. And I want to mention especially the computility abstraction technology because this subgroup also is founded based on this technology as to perform a unified computility abstract model and a matching programming model and interface for the heterogeneous resources. And based on the computility abstraction, so we built the cross-architecture compilation and adaptive runtime to make sure that AI models and applications can migrate from like NVIDIA GPU to AMD, like to Intel or Huawei, these all types and AI chips. And also the computing offload and integration subgroup is to mainly focus on the DPU, and especially to achieve the decoupling goal between the DPU hardware servers and the cloud platform. And also the heterogeneous distributed training subgroup. And so we may facing the scenario that there may be many multiple types of AI chips in the intelligent computing center. So this subgroup, the goal of this subgroup is to realize a hybrid training of a large model across multiple types of intelligent computing chips. So it also has 3 key technologies. The first is a heterogeneous training task splitting, and to aiming to build an open AI framework that can according to the different performance of different chips, and can do some flexibly and non-uniformly decompose the distributed training strategy on different chips. The key technology also has a heterogeneous training performance prediction as to build performance prediction models and tools and to achieve the automated and the intelligent generation of the optimal distributed strategies. And the key technology 3 is the heterogeneous hybrid communication, and is aiming to build a unified heterogeneous collective communication library as similar to Nico, and to enable the collective communication operation like all reduce, all to all, and these operations can among the different AI chips. I mean that you can do the like the all-to-all operation, collective operation that between NVIDIA and Huawei ASIC. So the last is a subgroup is a security subgroup. The security subgroup focuses on providing the security solutions or recommendations based on the potential security risks, and to solve the risk problems that the computing network that may face. Okay, so the last part is CFN for the AI solution. So there are two scenarios that I list. The first is the integrated computing and network scheduling for the mobile service scenarios. And we may know that in mobile service scenarios such as cloud gaming, XR, or autonomous driving, or the UAVs, you need to schedule the computing and the network and the service together. But now it's very hard to achieve this goal. So we aim to achieve the integrated computing network scheduling and through the work of the ubiquitous scheduling subgroup in the CFN working group, and to guarantee the service SLAs and minimize the service interruption time during the item is moving. The use case for the AI scenario 2 is the cross-architecture deployment and migration of the AI applications. So, especially in the scenarios of IOV, that AI application code and models, they may deploy it on any chips in different data centers. Maybe some data centers we use NVIDIA GPU, and some data centers we use Huawei Ascent, or others data centers may use AMD AI chips. So we need to deploy the applications also not only on NVIDIA but also on Huawei Ascent or AMD. So our computing native subgroup is aiming to solve these problems and to make the AI applications can migrate freely from any heterogeneous AI chips. So coming to the last is this is information and links to the CFN working group. So welcome to join our working group to discuss the solutions and make some and deliver codes. Thank you.